All right, so this is going to be the fourth and final video that I talk about the center of mass with relation to calculus. And in this particular video, I'm going to focus on something called the Theorem of Pappus. Now, what this does is it refers to a plane region R, which I'll just kind of draw some shape here. We'll call it R. And I want it to be entirely on one side. It doesn't matter whether it's left, right, above, below, some other line, which we will call L. And we are going to rotate this region, this R region, about this line. And it's going to kind of come out in 3 dimensions. So it's going to rotate all the way around. And it's going to kind of look a bit like a reflection on this side. And it's going to keep coming around all the way until we get a 3-dimensional solid. And so it's going to look kind of like a donut, where if you cut open into it, this would be the shape that you would see as a cross section. And we call this a solid of revolution. And what the theorem of Pappus does is it allows us to find the volume of this solid by multiplying or finding the product of the area of this region, so this thing I'm shading, and I'm going to find that area and I'm going to multiply it by the distance that the center of mass, or the centroid, travels inside of that solid. So I'm going to need to find the center of mass, which I'm going to kind of guess is right about there. And I'm going to need to see how far it travels inside of this solid to see what the volume is. And so the volume is going to be found by multiplying the area times that distance traveled. Now, important things to know is, if I want to find this area, sometimes I can use a geometric formula, like if it's a circle or a square or a rectangle or a triangle. It can sometimes be a pretty easy thing to find just the area. But sometimes I have to actually use calculus. Like, for example, the shape that I drew here, I would have to use calculus because it's not a nice, pretty shape at all. However, when I go to find this distance, that is a nice, pretty formula. It's typically the circumference of a circle, but what you need to do is you need to figure out how far this center of mass is from the axis of revolution, and you'll call that your radius of the circle, and you'll find the circumference using that radius there. So you may or may not have to use calculus to actually find that center of mass. Sometimes you do, sometimes you don't, depends on the shape. And then you're going to find out how far it is, again, that distance from the center of mass to the axis of revolution, and use that to calculate the distance that it travels around inside of the solid. So I think that's going to help if I go over this example that I have right here, which is a torus formed by rotating a circle of radius 2. So let me go ahead and draw myself a circle. And we know that its radius is 2 centimeters. And we're going to rotate it about a line somewhere in the plane, which I'll go ahead and just kind of sketch a quick line right here. And we know that the distance from the center of the circle to this line is 5 centimeters. And so when we revolve this around, this actually will look like a donut. So we're going to revolve this around. We're going to have the same looking circle over here, same 2 centimeters. And so, like I said, this is going to definitely look a lot like a donut, because if I cut into it, it's just going to be a circular cross section. It's going to have this part as what it looks like when it's cut open. Now, what I'm going to do is I'm going to find the volume of this torus using this formula that I did up here. So the first thing I need to find is the area of this cross section, so this pink shading thing that I did. Now, again, this is a circle that I have rotated or revolved around a line, so I need to find the area of a circle, which is pi r squared. So that's going to be pi times the radius of my circle was 2 centimeters squared. 2 squared is 4, so it's going to be 4 pi square centimeters. That's the area of the little circle. And then the other thing I need to do is I need to figure out if this is my center of mass, which it's a circle, so it's the center is the center of mass. I need to figure out how far this thing travels as it goes throughout the solid, as it goes all the way around on the inside of that donut. So what I'm going to do is I'm going to use, again, the circumference formula, where I do 2 times pi times the radius. Now, in this case, the radius is not the little circle of 2 centimeters. It is the big circle So it's the distance from the center to the axis of revolution, which was 5 centimeters. So I'm going to do 2 times pi times 5 centimeters. And 2 times 5 gives me 10 pi. And that's just centimeters, it's not square centimeters. So when I want to find the volume, all I have to do is multiply these two things together. The area times the distance that the center of mass traveled inside of the solid. So that's going to be 4 pi square centimeters times 10 pi centimeters. And 4 times 10 gives me 40. Pi times pi gives me pi squared. And centimeters squared times centimeters gives me cubic centimeters. So that is going to be my final exact answer. If I wanted to know what it was, um, approximately I can do 40 times pi squared, which gives me about 394.78 cubic centimeters. So there's the volume of that particular torus. But I do want to extend this a little bit and say, well, what happens if I just have a general torus? Maybe that I don't particularly know right offhand what the small circle's radius is, what the cross section's radius is, and maybe I don't know how far it is from the center of that cross section to the axis of revolution. So I'm just going to treat it like the circle's radius is little r, and the big radius, the radius from the center of the circle to the axis of revolution is capital R. So again, instead of having 2, it's little r. Instead of having 5, it's big R. So all I'm going to do is kind of tweak my formulas a little bit where the area is pi times little r squared. Again, little r is the radius of the circle. And d is going to be 2 pi times big R because that's the radius from the center to the axis of revolution, the center uh, of the cross section to the axis of revolution. And so when I go to find the volume, we're going to multiply those two things together. Pi r squared times 2 pi big R. And so keep the 2 out front. Pi times pi gives me pi squared, little r squared, big R. And whatever units we'll use, we just got to make sure they're consistent like it was centimeters and centimeters. But that is going to be the formula for a general torus. And I do want to mention before I'm all over that this is, again, the theorem of Pappus, and it does find the volume. There is a similar theorem that does find the surface area of a solid of revolution using a similar method to this. It's not exactly the same, but it is not the theorem of Pappus. It has a different name. But this was specifically the one I wanted to go over. If you have any questions, please feel free to let me know. Otherwise, have a great day.